Good morning everybody. Günaydın. Chicago'ya hoş geldiniz. Ben Ercan Alp, Burhan'la birlikte konferansı düzenleyenlerdenim. Bu arada tabii gizli düzenleyicimiz Haluk Bey. Ona da teşekkür edeyim. Let me invite a person for whom we are very grateful, an old colleague and an old bosses of the boss at the moment, actually. Eric Isaacs. Eric is a physicist. He's currently the provost of University of Chicago, but prior to coming to University of Chicago, he started his scientific career at Bell Labs, and then our paths crossed when he was interested in inelastic X-ray scattering. Together we have worked, and Eric then came to Argonne as the founder-director of the Center for Nanomaterials, and then he moved up to become the director of Argonne National Lab, and he couldn't be stopped. So Eric is currently the provost of University of Chicago. He's a great friend of young scientists. I know he cares deeply about young scientists, so I'm really privileged to invite him to the stage. Eric.
Well, welcome to the University of Chicago. We're really delighted to have you here. In particular, I'd like to welcome the Minister, Consul General, and President of the organization, TASSA. We're really delighted to have you for many reasons here today, especially excited to hear all the discussions about this interdisciplinary work that crosses through science, applied science, engineering, and social sciences. Before I make my few comments, I do want to thank Professors Sandici for helping to organize, and I want to especially thank Ercan Alp because, as he said, we have been collaborators for many years. In fact, even co-authored a few papers together for really all the work they did to put this together. So we're delighted to have all of you here. I also would encourage you over the next 2 days. You'll see the Booth School building here, Harper Center, which is spectacular. Get a chance, walk across campus, take a look at all the exciting things going on. Just kitty corner to here is our new home for the School of Economics here, Economics Department in particular, called Saye Hall. Spectacular, an old building, but that's been refurbished for a modern economics department. Right next door to the other side is the Oriental Institute. Many of you may actually have been there and seen some of the artifacts they've collected and some of the work they've actually done on Ottoman Empire, Turkey, and many other things. So I'd encourage you to get out and explore the campus, which is really growing and becoming more and more spectacular. So I'd just like to make a few points about one simple fact, which is that research has changed in the last 10 to 20 years. It's a different type of thing than it was years ago. It's much more interdisciplinary, as we've already heard. There's much more need, as a provost would know well, for costly instrumentation. There is a need for much larger data sets and bringing all that together. And we also need lots of collaborative space, a way to think differently about each of the problems, the major problems that we face, because we need to bring multiple scholars together. We need to bring scholars, industry, and national labs together. And the overarching need here really is that we need to take research in a new way. We need to look at it, think about research, but also take it out in some sense to have an impact, if I can say, in the real world. We need to think about how we take basic science and make differences in energy. We take basic science, have a difference in impact in health, and even take basic science and have an impact on crime and terrorism around the world. So what I'd like to do is give a few examples, but to start, thinking back 40 years, if you think 40 years about what research looked like, if you look at many of you, actually many of you were not around 40 years ago doing research. I wasn't. But if you go back 40 years, you'll see a lot of publications were done by individual authors or individual labs. You'll see that research instruments were possible to be owned by individuals. You might have a small computer in your lab. You might have a laser in your lab, but everything was done on a much smaller scale. And in many ways, and we had corporations like Bell Laboratories. Ercan mentioned I came from Bell Laboratories that did a lot of research, but that research actually was delivered toward outcomes. That wasn't done necessarily in universities. But those national labs, those industrial labs are by and large gone. So they're not really doing the kind of research they used to do. So that was 40 years ago. Is what we had. Now, as we've already heard, we're talking about much more interdisciplinary approaches to science, to technology, to social science. We need access to globally owned research instruments and data. If you think of just about pure science and just take, for example, astronomy and astrophysics, something, or cosmology we do here at the University of Chicago, you can't build a telescope anymore for only $10 million. We owned our own telescope up in Wisconsin back in the 30s and 40s, called Yerkes. Today, a telescope's $1 billion. It's the same cost as a synchrotron. It's a big deal. You can't do it alone anymore. Same thing with computing. You can't just build a computer in your laboratory anymore. They're $100 million, $200 million and consume 40 megawatts of energy. So we're talking about a very different scale of things to make a difference in the world, not to mention high energy physics. And access to collaborations is not just within the academy anymore. From a university perspective, we need to work with industry. We need to work with collaborators. And so it's really a different world. Now, you've heard a lot of people say this before, but what I'd like to do is just give two examples from here at the university and Argonne National Lab that really highlight how that has changed. The first example is a recent institute we set up here at the university called the Energy Policy Institute at Chicago. Now, this institute does cutting-edge research to test new approaches to the expanding need for energy across the world, but also at the same time to think carefully about how we can apply low-cost reductions to the carbon that are produced by most of those energy sources being fossil fuels. So this kind of a problem, of course, is a massive problem. We're not going to solve it in any one place. But even the Energy Policy Institute requires economists at the university, it requires climate scientists in the university, policy experts, and also in multiple partnerships. It requires partnerships with governments, for example, because it's got to be related to policy. Even if you have great data supporting a way to reduce carbon output, you need to have policy. You need connections, access to data, and you need influence over those policies that the data can inform you about. So you need to think about, when you're thinking about global challenges like energy, it used to be smaller, cheaper, faster. And as director of Argonne, when I first started, I would say, let's just build a cheaper solar collector and everyone will adopt it because it'll be cheaper than coal power plants. But in fact, it doesn't work. You need to have policy in order to drive that change. It's not just getting a better technology as much as I would wish it was. It's just not. So the Energy Policy Institute has done this kind of wrapping around all these different institutions, from industry to government. Just give you an example. A few years ago, the Energy Policy Institute was working in India, in Gujarat. It's one of the most industry-intensive states in India. With their manufacturing plants. It produces about 15% of all the pollution in India, and any of you who have been to India recently will know how hard it is there to reduce pollution or how bad it is. They were able basically to do correct measurements through careful data assessments, changing the economic incentives for how those inspections were done, and ultimately reduce the carbon output of these manufacturing plants by 5%. So you think about science, which is asking the question, how much carbon are we producing? You think about policy, which is how does it affect the reduction of that carbon? It all has to come together. It's not a simple one-person, one-lab problem anymore. Second example I wanted to give is around energy storage, something that Argonne National Lab has taken up. And those of you who know Argonne will know this is one of the key research programs. Everyone thinks a battery is simple. Everybody has a phone in their pocket that's got a battery. Batteries are actually very complex objects. So there we put together a 14-institution team to solve a battery problem. Of course, if we can solve the battery problem, we can have electric vehicles and we can have solar and variable energy sources on the grid. You need to solve the energy storage problem. So one would think, okay, we just need a couple of electrochemists in a laboratory and we can build a better battery. Of course, that's not true. You need electrochemists to solve the fundamental challenges in batteries. You also need engineers to design the battery itself. A battery is a complex object. And even most importantly, you need industry involved, because if you're going to build a battery on a laptop, on a benchtop here, you're not going to be able to know that it's scalable, manufacturable. So thinking about this Joint Center for Energy Storage Research, we have each of those components inside the tent, so to speak, solving that major problem. So when I mention multidisciplinary, I hope these two examples are really clear that this is really what we're talking about now. The world has changed. So let me talk to you just for 3 minutes about the University of Chicago. We were founded 125 years ago, and as an institution, from our very inception, we were driven by really a singular idea, and that idea was that one could create and continuously renew a university that was focused on rigorous, intense inquiry and analysis. That simple idea is what's carried us through for 125 years. And one example of this at the University of Chicago, just in the last few years, is that we've started to bring in engineering. And you're looking at me and saying, you had no engineering at the University of Chicago? You know, we're an Ivy Plus school. we're actually the only Ivy Plus that didn't have engineering 10 years ago. So it's a very interesting and stunning statement for me to make as provost. But the reason we didn't have applied science and engineering here at the University of Chicago was primarily rooted in a deep concern of our faculty, which was a really honest and good one, which was that they wanted to focus on pure discovery. This university was really about pure discovery for many years. That discovery, of course, was important and drove a lot of 89 Nobel Prizes. You almost said it, but didn't quite. I mean, it was really a great thing for the university. However, we ended up not having engineering because of that commitment to discovery. So, in fact, it was a good thing, I would argue, that we didn't have engineering, we didn't have applied science at this university, because it enabled us as a group to really rethink in a modern age in the 21st century what that could look like, what this interdisciplinary engineering could look like in the 21st century. And so that's basically where we are now. It gave us a unique opportunity. And so I'll just briefly say what we've done. In the past 5 years alone, we've created a new institute for molecular engineering. It's the first establishment of engineering here on campus. It's oriented, basic research oriented, but with the idea that it's multidisciplinary right from the start. We have immunologists in the same building with physicists, chemists, and engineers. So they're able to think about problems that are big and at the same time have the science that underpins that important science, that important engineering. We have problems in quantum information, energy storage, water, immunology being solved in that engineering group. We created, and that's a very important component. The other component we created right here in this building was a Center for Entrepreneurship and Innovation called the Polsky Center for Entrepreneurship, for Innovation and Entrepreneurship. We didn't have this 15 years ago. This was created as an outlet for a lot of the applied science that just started rolling, where you could think about inventing a new battery, but then how do I create a business around a new battery? So those kinds of things. So now, finally, we're able to think here at the University of Chicago as to how to implement a lot of these types of multidisciplinary types of activities. So, what I would like to, I want to finish because I think we have to get going here, but I do want to say a few things about research and globalization, because it's something that I think we're all thinking a lot about in this room and across all universities. Research, of course, impacts such as energy research really transcends borders and languages. This university has expanded its work across the world. We have now activities in 40 countries, Turkey being one of them. A lot of the research I mentioned, the Oriental Institute going on, is really built on global centers, on global interactions, thinking about big science, thinking about engineering. It is in this spirit also that we welcome all of you here. I do want to say, just finishing off here, that we have had a long history of engagement in Turkey in this sort of multidisciplinary research. I mentioned the Oriental Institute. We've been doing excavations with Turkish scientists into the 20s, studying Turkey, studying the Ottoman Empire, we have a Turkish studies program. We send students there. In fact, we have 64 students from Turkey here on campus, currently here from Turkey, who are studying at the University of Chicago. And we are grateful to have distinguished faculty here, as we know, from one of our organizers, but also people like Ali Hortescu in economics, Hakan Kartike in Near Eastern languages and civilizations, and of course Ercan. And so we're really excited to have all of you here today. We're excited because we've been engaged with Turkey and Turkish scholars for many years, because we're excited about multidisciplinary research, because we think it is the path forward for solving some of the grand challenges. So now, very much enjoy and look forward to hearing what the conference has to say and to the minister's comments. Thank you.